In this video, we'll be talking about the best fit linear regression model. In a recent video, we created a scatter plot. Each point tells us how far each woman walks per day and her weight in kilograms. Since our data points are in the approximate shape of a line with no outliers, we can use a linear model to analyze the relationship between our variables. Residuals are the lengths between each point and the line. The points below our line have a negative residual, and the points above the line have a positive residual. If our line is the best fit, the sum of our residuals will be equal to 0, as the positive and negative residuals will cancel each other out. But how do we determine where to place our line to ensure that it is the best fit for our data? Let's start by recalling that the equation of a line is y equals ax plus b. There are multiple ways to determine the values in this equation, a few of which are linked below. Let's say we use the TI-84 to determine the equation of the line and get this display. Let's talk about what that means. Look at the label on the y-axis of the scatter plot. In this study, y represents the weights of women. Now, look at the label on the x-axis. In this study, x represents the miles walked per day. A is the slope of our line. Slope tells us the difference in y per x. In this example, the slope is negative 4.27. The difference in weight per mile is negative 4.27. In other words, for every additional mile the women in our study walk per day, their weight is 4.27 kilograms less. B is the y-intercept. The y-intercept is y, or in this case weight, when x, or in this case miles walked per day, is 0. According to our model, a woman who walks no miles weighs 90.8 kilograms. However, since all of the women in our study walk between 1 and 6 miles, it is not reliable to make a prediction outside of this range. Let's take a look at how to use our model to make predictions. Our equation tells us that weight is equal to negative 4.27 multiplied by the number of miles plus 90.83. We put a little hat on the weight to signify that it is not the actual weight, but a predicted value that we can get from utilizing our model. Recall that a residual is the difference between the actual data and our predicted value. From our graph, we see that a woman who walks 3.5 miles per day weighs 82 kilograms. If we had to predict the weight of another woman who walks 3.5 miles, we would use our best fit equation. Weight equals negative 4.27 times 3.5 plus 90.83. Weight is equal to 75.89 kilograms. But we know that a woman who walks 3.5 miles in our study weighs 82 kilograms. The difference between the data value and the model value is the residual. 82, the data value, minus 75.89, the model value, is equal to 6.11 for this case. Here's what we've learned in this video. A best fit regression line can be drawn if a scatter plot indicates that there is a strong correlation. A residual is the distance between each data point and the linear model. All residuals in a dataset should have a sum of 0 if the line is a best fit line. The best fit regression equation can be found using a statistics calculator or spreadsheet. Slope tells us the change in y per x. The best fit model can be used to make predictions within the range of given data.